4 is exactly what we're doing. So we're still just graphing, sketching on the linear inequalities, except now we're going to put them into use for word problems. So this is where it starts to get a little bit. So if you're struggling at all with being able to graph this, okay, on paper, you need to get that figured out because you're not going to be able to do anything if you can't graph just an equation. All right. So now we have to be able to read the question out and then decide how it's going to look on the graph. This is the hard part. So we need to buckle down here and go through it. So let's look at the keep in mind. Normally I don't read through them, but this one is a good one. To solve an optimization problem, determine which combination of values of two variables results in a maximum or minimum value of a related quantity. When creating a model, first represent the situation algebraically. Include a defining statement of the variables, a statement describing the restrictions on the variables, a system of inequalities that describes the constraints, and an objective function that expresses the quantity to be maximized or minimized in terms of variables. Okay, so they went through and gave you the whole gamut here, but you're not going to use the whole gamut just yet until we get to about 6.6. Okay, so the first thing that you want to do is write a defining statement of your variables, and then you want to write the restrictions out. So I'm going to write restrictions. Constraints. And our ultimate goal is our objective, our optimizing statement. So what they're going to do, the objective here is to sketch and shade regions in which we are going to find a coordinate within that region that's going to give us our maximum value or our minimum value. So for example, if you wanted to find out the profits of selling hot dogs and hamburgers, we want to find the maximum amount. So that would be where we would put our optimizing or our objective statement. Okay? So let's look at the first question. So again, there's two tips in there that are really good. When you read an optimization problem, identify the quantity that is to be optimized. Look for keywords such as maximize, minimize, largest, smallest, greatest, or least. Restrictions on the variables such as x is greater than or equal to 0 and y is greater than or equal to 0. If you're working with positive real numbers, are also constraints and should be included in the system of linear inequalities. So we'll get to that in a second. So here's how this works. 4 teams are traveling to a baseball tournament in cars and minivans. Each team has no more than 3 coaches and 10 athletes. Each car can take 5 team members. Each minivan can take 8 team members. No more than 5 minivans and 11 cars are available. The school wants to know what combinations of cars and minivans will require the maximum or minimum number of vehicles. Create and verify a model to represent the situation. All right. So they want to know what is going to be the maximum amount of vehicles to take or the minimum amount of vehicles to take in order to get these teams to their tournament. Okay? So we're dealing with the first thing we want to do, and this is where I should have put this down, is your defining statement. I'm just going to erase this for a second. So our defining statement is minivans, cars. Okay? So I'm going to use minivans and cars. And the vehicles used will be the number of cars plus the number of minivans. And that will help us get our maximum number of cars and minivans and our minimum amount of cars and minivans. Okay? So the next thing I want to do then is write my restrictions down. Now I'm talking about cars and minivans. So what would it be that I would have to restrict my domain and range to for cars and minivans? Whole numbers, right? Now my axes, okay, my x-axis will be the cars. We can make one of them our y value and one our x value. It doesn't matter. But the fact of the matter is this. Cars will have to be an element of the whole numbers. Can't have negative cars, can't have parts of cars. And the minivans will be an element of the whole number. Okay? So when I were to graph it, what would my graph look like? Where would it be located? Yeah, which quadrant is that? Top right, which is quadrant 1. Correct? Okay. And then, would I have it all shaded in? No, I would have dots. Dots on all the whole numbers, because you can't have parts of it. So it would look like a dotted, instead of shading, I'm just going to put dots on all of the intersections of all the whole numbers. Okay? So we've got cars and minivans. Now the constraints. Here's the meat and potatoes of this guy. So basically, what I'm going to tell you to do today, and this is what this 6.4 does, is it's read the question and put this information down. You don't have to solve today. We don't need to solve. We don't need to graph it yet. We just need to be able to do this. So it's practice for you to do it. Okay? So the first constraint, I look at it and I try and get this figured out. I'm gonna ignore the athletes for 1 second. But each car can take 5 members and each minivan can take 8 members. So how do I show that on a Okay, well actually let me do this different. Sorry. I'm gonna jump over that for a second. The next thing I want to look for is I want to look for statements that jump out at you, that list your constraints. So one of the statements that jumps out at me is it says no more than 5 minivans. Okay? So then I put here, minivans has to be less than or equal to 5. And how many is the maximum number of cars that are available? Okay. So those are the statements that I look for first. Those are the ones that I really want to focus in on. The ones that are very specific. And what you're going to find is that they're going to mostly be horizontal and vertical lines if you were to graph it. Okay? All right. The next thing. It says each team has no more than 3 coaches and 10 athletes. So there's 4 teams. Right? 4 teams. The maximum number on one team is how many people? 13. So then the maximum number of people to transport is how many? 52. 52. Right? 4 teams times 13. That's the maximum number, right? So now when I look at how many each minivan and how many each car can take, all right? So if I'm putting them all in a car, how many can I fit in a car? 5. So I go 5C plus, how many can fit in the minivan? 8M has to be less than or equal to 52. All right? No more information is needed here. Okay? My defining statement explains to the person reading this, not reading the word problem, what each axis is going to look like. Minivans, cars. The restrictions tells you whether or not you can have whole numbers, real numbers, integers, natural numbers, whatever it is. Yeah?
Should it not be greater than 52?
No.
No.
The max.
The maximum number is 52, right? That's the maximum number of people you can take. Right? So then that means it has to be less than or equal to 52. So if you had 4 teams, 3 coaches, 10 players per team, it would be 5C plus 8M equals 52. But it's got to be somewhere less than that. Maybe a team only has 1 coach. Maybe it's only got 8 players. Fair enough? Yeah. Okay. The constraints. These are the graphing parts. This is what I want to graph. The objective, the optimization statement, it's the statement that we use after. That's what we plug our values into. Okay? So now, I'm going to show you how I would finish this question if need be. You do not have to yet, but this is how it works. Okay? I'm going to graph it. I'm going to use the help of a calculator. Actually, I'll start like this. Okay? Okay. So, notice I drew it out so that I only have the positives, right? So 0 here. Okay? Now, mark off our axes. Doesn't matter which one's which. I'll put the minivans up here, and I'll put the cars on the bottom. Doesn't matter. Does not matter. I can do it that way. All right. So, what's the first thing I do to graph them?
Make it an equality.
Make it an equality. So m equals 5. What is that going to look like if m is in my y-axis?
Horizontal line.
Horizontal line, that's right. So, and it's solid, right? M equals 5. Okay? Do I shade above or below that line? Below. M is less than or equal to 5, right? So I'd shade down here. Again, should I be shading this?
No.
No. I should be putting what?
Dots.
Dots, that's right. But I'm going to shade it for right now. Okay, until I get my little area, and then I'll go back to dots again. Just so that I have an idea. Okay? The next thing. C is, so what is that line going to look like? A vertical line. Somewhere out here, right? And which area am I going to shade? To the left of it, smaller than it, right? But I don't have to shape above this one because it's already been taken out, so it's here. So there's my shading right there. Fair enough? Okay, now I'm going to have to graph that guy. Alright, so I'm going to graph it. What's the easiest way to graph it? Well, we'll do it this way. 8m is equal to minus 5c plus 52. M is equal to minus 5 over 8c plus, let's find my intercept, 52 divided by 8, that would be 6.5, right? Okay, so that would be somewhere right about here. Okay, now this one here, so like I said, I'm going to graph it a little bit better than I'm going to do right now, but I just want to show it to you. Okay, then I would go down 5, so somewhere over here, and across 8, so it'd be somewhere over here. Maybe in here, I don't know. Down like that, right there. Okay? And then where would I shade on that one? It's less than that. It'd be somewhere more or less in here, like that. Okay? So now that's where all my dots would go. On all the whole numbers. Okay? Now, I'm jumping way ahead here. I want to show you the end game. Show you the end game because it's sometimes hard to figure this out if I can't see what's coming. So I'm going to show you the end of it. The end of it is this. I want to find the values that will give me a maximum number here or a minimum number. So how many cars, how many minivans will give me a maximum number of vehicles and how many will give me a minimum. So what I do is I take my, what we call our corner points. Those are our intersection points that surround what we call, another word, this new feasible region. The feasible region is the region that I shaded that satisfies all of them. Okay? So let's go back again and let's look at this one more time. So I'm just going to put it on this graph now. And I want to change this. No, I should be good. Okay, so the first one was what? Y was less than, right? Was less than or equal to 5. So there it is there. Oh, okay, so I need to make this bigger. Just a second. Grid range. Minus 10. Let's do that same thing here. Minus 10. Tab 10. Okay, so there it is. But what did I do wrong here? Well, I don't need this side, right? So let's go back to my grid range. And instead I'm going to go minus 1 here.
Or 0.
And minus 1 or 0, but then I would lose my axis. I like to keep the minus 1s in there. So there's what we got right there, right? Okay, it's a little hard to see, I guess, that dark pink. Okay, so now the next one was x was less than
8.
equal to 8. And there I have it. So there's my intersection point so far, right? Okay, so you want to flip the light switch for me? This would be a lot easier to see it.
It should be 11 to 11. Yeah.
Should be 11?
Yeah.
I thought so. Okay, so let's clear this, see if I can delete that and put this in as 11, right? I think that was right. Okay, so I got enter. So I got to go change my grid range again. Grid range, now this guy right, I need to go to, let's say 20. There we go. So this darkened area right here, okay, that's my, oh, axis is a terrible color here. See if I can change that back to a color that we can see. Options, graph paper, colors, yes. Thank you. And background, graph, legends, grid lines. Dark, niche, close. Do something dark. Black. There you go. And that didn't help me much. So where was that again? Graph paper. Colors. My axis. I want to hit black as well. That's my. Well, I really changed things a lot. Okay, sorry, it's a mess. All right, so what was the last equation?
5.
5 cars,
Plus 8.
Right?
8 is
Plus
equal to or less than.
8 m's. Oops, I guess I gotta do axis. Cars are at x, right?
5x plus 8y. Oh, yeah.
No.
No. 5x plus 8y.
Is
8y.
less than
It's
or
less than or
equal
equal
to.
to 52.
Equal 52. And there we go. So that's a little easier to see now. Okay. So far, pretty decent. All right. So now what I'm looking at. So now what I would do, this region right here, this is my feasible region right here. That's the shaded region. So now what I would do is I would take, there's the outskirts of it, right there, and right there. I would take these 3 coordinates. So this guy right here would be, looks like 10.5 and 0. This guy right here is
2.5 and
5, right?
yeah.
2.5 and 5,
Not the one 0 and 5.
0 and 5, right? So those are my 3 coordinates. So now what I would do is I would take my optimizing, so V equals C plus M, make a quick little table, just like that. What was my first point? 0 and 5, right? My second point was 2.5 and 5. What's the problem with that one?
That's not a whole.
It's not a whole number. I can't use it, right? And this one also is 10.5 and 0. So neither one of them, I can't have half a car. Okay, we'll solve it just for giggles. You know what, right? So there's 5, right? So 2.5 and 5 is 7.5, and then this would be 10.5. Okay? So what's the maximum amount of vehicles or minimum amount of vehicles I need? I need 5 minivans in order to make this happen. Okay? But this question, like I said, is not set up to solve. It's just set up so that you understand you have 4 pieces of, or 4 information bulletins defined, so to speak. Defining, restrictions, optimization, and constraints. Okay? So all you're doing today, they may ask you to sketch them, but just go through page 163 to 165 today and just write this stuff out. That's all I want today. Okay? If you have time at the end of class and you want to graph them to work on that, then by all means. But for right now, we need to be able to write this out on it. Any questions about that? It's going to take some getting used to. So again, defining restrictions, optimization, and constraints. Those are the things that you need. All right?